Hello everyone. Today we will discuss this stereochemistry part. In this presentation, we will discuss history behind the stereochemistry, definition of stereochemistry, and some important another definitions, along with the what is meant by isomers and types of isomers, and in detail some constitutional isomers, or it is also called as a structural isomers. This stereochemistry mainly it is founding fathers of the stereochemistry is the Biot is the scientist first reported that solutions of many naturally occurring compounds rotate this plane polarized light during the period 1815 to 1817. Further, this Pasteur recognized in 1850 that the optical activity is due to this asymmetric arrangement of atom in a molecule. The Van 't Hoff and Liebel describes in 1874 how the atoms of molecule are actually arranged in a space, which is reported by this Van 't Hoff scientist. The stereochemistries are mainly two subdisciplines. One is static stereochemistry. It is nothing but a three-dimensional structure of any organic compound. Study of this three-dimensional arrangement of atom of molecule in a ground state. Further, second one is dynamic stereochemistry, which is nothing but it describes the steric relationship in molecules as they change from one state to another. Well-known example is this during the chemical reaction, the steric properties are changed when the reaction was carried out. There are some definitions. Structure includes both constitution and configuration. Then constitution is describe the kinds and other order of the bonds and atoms or atom groups in a compound. Then configuration is nothing but different spatial arrangement of atoms or group of atoms of compound with given constitution. The stereoisomers, the compounds with the same connectivity but different spatial arrangement in a space. These are two types, enantiomers and diastereomers. Then conformation describes the different spatial arrangements of atoms or groups in a molecule that arise due to rotation around a single bonds. These isomers are nothing but same molecular formula but different structural formula, or different compounds with same molecular formula is called as isomers. These isomers are divided into two types majorly, constitutional isomer and second one is stereoisomers. The stereoisomers are mainly divided into configurational isomer and conformational isomer. These configurationals are again two types, that is geometrical and optical isomers. These optical isomers are not again divided into these two types, enantiomers and diastereomers. Means mainly isomers are divided into two, constitutional and stereoisomers. The stereoisomers are configurational and conformational isomers. Configurationals are geometrical and optical, then opticals are enantiomers and diastereomers. These constitutional isomers are somewhere it is called as a structural isomers. These are mainly 5 to 6 types, one by one: chain isomers, positional isomers, functional isomers, invertomers, metamers and tautomers. Today we will discuss this chain, positional, functional and tautomers and invertomers. These structural isomers having same molecular formula but different structural formula. This different arrangement of carbon skeleton means the bonding connectivity is different. In case of constitutional isomer, in the specific definition is the molecules with the same molecular formula but different bonding connectivities are called as constitutional isomers. Means different structural formula, it means that the different bonding connectivity. In that, the first type is chain isomers. This different arrangement of carbon skeleton, similar chemical properties having a slight difference in physical properties and more branching in forms a lower boiling point. Second one is positional isomers. A functional group is in the different position. This is called as positional. Functional groups, they are different functional group, different chemical and physical properties. The structural, first one is chain isomers. When example is butane, it is a straight chain, but this 2-methyl propane having the same molecular formula called as C4H10. When it is a C4, it is, these are 3 plus this 4. This is methyl cyclopropane having a same molecular formula, but it is different structural formula. It is branched and it is a straight chain. This second one is positional isomer. When the position of this double bond is different, in case of first one is, it is 1 in, means double bond is between 1 and 2, and in case of this 2 pentene, it is at the second and third position, double bond between second and third position. So it is called as positional isomer. This positional isomer will be explained by taking another example. That is 1 chloropropane at the position of chloro group is different. 1 chlorobutane, it is position of chlorine group at the first position. Here is the second position. It is 2 chlorobutane. It is not 3 chlorobutane because this is one number and this one is the second number. It is, third example is 2, not 3. There are 2 more structural isomers, C4H9Cl, but they have a longest chain of 3 relative positions on benzene ring. It is ortho, it is meta, and this one is the para. That's why it is 1,4, it is 1,3, and it is 1,2 dichlorobenzene. These are the positional structural isomers of each other, or structural positional isomers of each other. Then functional isomers, when we consider this same molecular formula called as the C2H6 and O. This is C2H6 and O. Count the C2, this is 1, 2, and hydrogens are this 2, 2, 4, this one is 5, and this one is 6, and this is 1 oxygen. This is also 1 oxygen, then 2 carbons, then this 3, and this one is 3. So 6 hydrogens are there. So it is methoxymethane, and this is ethanol, means the functional groups are different. That's why it is another functional group alcohol, it is another, it is ether. So having different physical and chemical properties called as functional isomers. Tautomers, it is ketoenol formation, having the same molecular formula, it is enol, and this is keto, tautomerize with each other. This is called as ketoenol formation, called as tautomers of each other. Then invertomers, it is related to the nitrogen atom, having lone pair of electrons, and this is substituted with 3 different, that is CH3, C2H5O, and hydrogen, and this is considered as a 4th group or atom which is substituted on this nitrogen atom. This nitrogen is considered as a chiral, isn't it? These are the interconvertible and non-resorbable mirror image of each other, called as invertomers. This is regarding classification of isomer, what is meant by isomers, classification, and only in detail of constitutional isomers, or it is called as structural isomers. In the next lecture we will discuss the stereoisomers in detail. Thank you.